I've chosen to present a topic called Breadcrumbs Won't Help, How Not to Get Lost in a Lambda Forest. The history behind that is a colleague of mine was debugging some code, and he said, I'm totally lost, can you help me? This is a real forest of lambdas I'm debugging right now. So, a short disclaimer, my job is to get things done. So that means I don't ponder over new styles of coding. I don't have the time to find new concepts or something like that. I'm here to state the obvious. Everything I tell you, you already should have heard once or twice. I've just found it's really sensible to repeat it over and over again. Yeah, so about me, I'm a software engineer at TeamViewer. I'm working on our core product as an almost full-stack developer, so I'm over basically all the languages we use except Java, and that means BlackBerry and Android are out. Other than that, I'm working on all our clients and on the server landscape. And sometimes I'm also acting as a trainer. It's something that's important to me to note that, because this is actually my first talk at a conference. Usually I'm training people who don't know anything about the stuff I try to convey. And this time I try to convey stuff I know everybody knows. Yeah, two other important traits that you should know are I'm a musician, and as a musician I like in music exactly the opposite of what I'm telling you right now. So lambdas and being a musician are yeah, quite the opposite. But the other thing is my brain's full with music, so I don't have time or energy left for storing code. And I'm also quite lazy. That means I hate memorizing things that should be obvious or that could be obvious. Yeah, our company, just a few quick notes about that. We have our headquarters in Göppingen. We have different development places all over Germany and even outside of Germany and outside of the EU. We have 28 agile development teams, and we are hiring. Yeah. A product that is also a key interest for the slides coming ahead. It's running on over 1.8 billion devices. We have 900 routers worldwide. We have about 7 million logins a day. That adds up to about 200 logins per second, which then create about 600 to 800 callbacks triggered per second on one server. Yeah, then that's not everything. I mean, we don't just do logins. We do remote connections, we do meetings. Those add up to about 21 million connections a day. So that's even more callbacks that are triggered in our systems per second. I actually didn't count them or measure them, but they must be over 20,000 callbacks a second that are triggered in our core systems. Yeah, all this is hidden in 1.8 million lines of code, and we are using about 10,000 lambdas in this code, which fuel about 28,000 different callbacks. Now, that's odd. It doesn't look like lambdas, right? Who of you has seen this picture in the last year or something like that picture? It's about microservices. The architecture, in German there's the saying, die Sau durchs Dorf treiben. That means that is the most in architecture I have encountered for a server landscape. You take chunks of your product, put it into smaller chunks, and then you try to communicate between those small chunks via events, via commands, and that is what triggers callbacks. Our landscape looks a little bit like this. Yes, we have central database storage, we have a master server, and all the other functionality is in providers' own processes around our master servers. Yeah, so this is how I imagine our callback landscape. There's lambdas everywhere. And as a programmer, you like to have a clear trail of thoughts. You have to you like to have clear structures. You like to have a path that leads you through your code, especially if you're trying to debugging some error. And what lambdas do is they come in, they take out a chunk of your code, put it somewhere completely different. They remove your code from the scope you're actually working in, and they help you to do things, do stuff wherever you need them, but probably not wherever you would expect them. Before I said I was a musician, that is what makes music interesting. You have a string, you have a flow, and suddenly something different comes in, and the original motive repeats somewhere else. Yeah. So these lambdas, they were introduced in C++11. That means for our systems, we learned about them about 4 years ago. Because we can't use the latest product everywhere due to different compilers who don't find them. Still, for me, these lambdas, they were really a cool thing. I started using them all over wherever I could. And I did some pretty bad mistakes. Now back to the basics. I think everyone knows how a lambda works, but yeah, that's how you define it. Björn yesterday in his talk said, if dealing with lambda, always use auto or create them using auto return type. Yeah, that's true. Then you have a capture. That means you can just pick something from your old scope and transfer it into the new scope, and you have parameters. So it's a callable, it's a function. You have different possible captures, like you can capture nothing, you can capture a variable by copying it, so by value. You can capture it by reference, and you have two things. Yeah, capture everything by reference, everything that you need, and capture everything by copy that you need. And yeah, this leads to a pretty interesting thing. Now, you could say, okay, I defined somewhere my captured variable outside of the scope of the lambda. I captured it by reference, so when I assign 0 to it, then it will become 0. It will have an effect on the effect outside. If you capture it by copy, then you basically can do whatever you want. And you even can capture this. And now if you don't follow a certain style of coding, like for example prefixing every member variable with m, then you end up with that thing. In this case, it's quite obvious. It says this, and captured is there, so it's not defined in the scope of the lambda, so it must be captured, and it must be a member of this. In this case, however, if the prefix is not there, you don't know that. And that's why I said I'm lazy. I want to know that at that point. Because if I don't know that, I will do mistakes. And that leads me to the first bug that I've encountered, that I've seen so many times that, that I don't want to see it. I don't want to make this a mistake anymore. It's about lifecycle problems. By the way, did anyone notice that's a mobile strip? I noticed yesterday when I went over the slides and stared at it like 10 minutes or so. Yeah, so lifetime cycle problems. That looks like some pretty harmless code. The thing is, we're working in an asynchronous environment. We have servers running which basically are stateless. They just try to remember just exactly what they need and nothing more. So when I ran this code, I got this. Obvious, right? So what happened? I'm using this pointer here. I copied it. Someone thought, oh, M captured. I wrote that M because it's better to understand. So captured. That could be copied. I can use it. Yeah, you can't use it because it was defined in the scope. It was a member variable. It crashed. The solution to this is quite obvious, I think. Just don't use this. Never ever capture this. Use a shared pointer. It will keep the object you're referencing alive until you don't need it anymore. So thanks C++ for that. And how to avoid the other problem, the key takeaway is never do that. Never ever do that. If you do that, I'll come to your office and hit you over the head with a shovel. Yeah. That's, of course, not the only problem I've encountered. Can you imagine what I want to tell you with this? Don't mix your stack. So, as I already said, we have averaging 17 million logins a day. That is 200 logins per second, which triggers communication between our clients and our core systems. Using many lambdas, many callbacks that are not lambdas, and mixing them up. Yeah, so the key question is that actually a problem? And the question you need to ask is, how often does it happen per second? If I'm on the client side, I won't log in 17 million times a day. I won't have to handle that that often, so I can opt for readability. If I'm in our core services, I need to opt for speed. I need to be very efficient. So the question really, I already told it, is how often per second does it happen? Because on our client side, that is a call stack. That's really, really okay. It does many things. It does many things I don't want to know about, so I just skip over them. This helps me with something. I'll come to that in a moment. The key thing I already said, if you're using lambda, use auto. I hate auto. Auto makes me, or auto forces me to think about what I'm reading instead of just reading what I actually want to know. So I have to move away from my actual problem and go into another scope of thinking, what is it that I'm confronting? So, for example, auto return type. Auto return type helps you in a way to not have to write much line, but it doesn't optimize for reading. So I want always to have all possible information. And I want to have type safety. I don't have type safety with auto. Someone recently, I think on Stack Overflow, posted some hideous method taking two auto parameters and returning auto, and asked, so I'm using this. I always fed ints, it's just doing a sum. Why do I get a double? That doesn't make any sense. Yeah, because someone in the whole project decided, oh, that's a nice function, I just want to use it with double. Yeah, back to the original call stack I was showing. This is a call stack that is doing exactly the same thing. So what's the difference? The original code was this. As I said, I'm lazy. I like to know what I'm dealing with. So I thought, okay, lambdas are new. I don't know how to work with them, but I know something about them. They help me not to use standard function pointers. I did it because I thought, yeah, okay, I don't want to change everything around this. I just wanted to introduce a quick callback. And yeah, then I added it. I bound something. I bound actually a variable to the lambda because I didn't know how to use a capture. But right now, I wouldn't do that this way. I would capture true, or in this case, I wouldn't even make it a parameter or a capture. I just would assume it's true. Yeah, and calling my function now does this hideous amount of stuff I don't want to see. So, as I previously said, for me in the client, it's cool to do that. Because I have the time, I don't need to optimize for speed. It helps me with my readability of the code. The cool thing, or the correct thing to do would be just to use the lambda and to use the auto return type and say, okay, the compiler does it for me. I don't need to cast, and then I get this neat small call stack. So the key takeaway from this is keep it clean. Don't make a mess when you don't need to. But if you want to be sure about what you're doing, it's okay to be typecasting lambdas. Yeah. The third big problem. Can anybody imagine what I want to tell you with this? I called it the reused concatenated problem. Yeah, so that's code I found, I think, 3 weeks ago. And yeah, I thought, oh, that's a good thing, that's a neat thing, that should be easy to debug. I put my breakpoint right here, in the beginning of that scope. And I ran across this, yeah, I skipped after the 5th call because I didn't get any information out of this. Thing is, this response callback was used, as is, for 4 completely different operations. Operations that weren't even in the same scope. So it was account login and a callback that was if we're doing a remote reboot. Now, of course, I was going to find out who did that. Yeah, me. So, the key takeaway I had was how do I solve this? How do I get the information I need right now? And I really was glad that I had a debugger and could change the code. So what I did was I introduced another variable and I just added some state information. In the beginning, I said breadcrumbs won't help. Yeah, that was a little lie. They do help because what I was doing is just throwing in the information I need to know where this callback came from. Yeah. Another problem I was encountering. Did you know that you can do recursive lambdas? So imagine something. I mean, a lambda is an unnamed function. Imagine something that pops up from somewhere. You're not sure why it's there. You don't know the code you're debugging right now. And you're getting caught up in something like that. Now this one is easy. It's just called once from inside. If you have a really deep rundown, your call stack will lose its origin. So you'll have a call stack like lambda, 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 lambda. At least if you have the settings I use with Visual Studio. And you don't know where you're coming from, you don't know where you're heading to. You're just somewhere in the code, in code from others. Yeah, don't do that if it's not necessary. It's better to just have names sometimes, to know what you're dealing with. Yeah, so the key takeaway from these two things is, of course, one of the main principles, don't repeat yourself. But don't forget that you sometimes have to debug your code. Add states, add some information that helps you figuring out where you actually are. Because if you don't get that information, you really might be lost. Now, what does this have to do with my original information about the microservices? As I said, we are using microservices. We are having them communicate with each other. We are having them doing stateless operations. We are doing them operations that are like a conversation between two parts. Yeah, now I'm lost. Yeah. In this landscape, it's important to know where you are, because your operations are divided upon several processes. Your callbacks are called from several processes. Your callbacks might end up in different processes. So that's one key thing I learned. Never do that if you're working with WTL. But yeah, it's possible. So you start one process and you hook into it, and suddenly you are running out of your own process in another process, doing stuff with lambdas, and debugging that is really, really, really the hell. Yeah. Now I'm frozen and I'm lost because I actually started the wrong set of slides. So I'll have to go out of my mind. If you're debugging lambdas, you've seen that evil call stack. Where is it? There. There's actually a neat little tool you can use to reduce that stuff you don't need. Visual Studio allows you to do frame filtering in your call stack. So this neat little tool, and I'd love to have the slides, but I don't know if they are even on this laptop. So this neat little tool helps you just to pick out the series of events you want to take. You can remove depth from your call stack. And removing depth from your call stack is one of the key important things you want to do when dealing with many lambdas. So right now, everything you've seen, these are problems that are small if you take a peek at one of them. But if you're in a landscape with 10,000 lambdas, concatenated into themselves, reused many times, then you just want to have a clean call stack. Yeah, so right now I feel a little like I might have wasted your time, because everything I said so far was hey, where is it going? There it should be going. Was something you should already know. And in this case, I say, do repeat yourself. Tell everyone. And as this thing triggered a really lengthy discussion at my company, I decided not to do so much of a talk. So the only slides that were missing were those for frame filtering. And I want to go to Q&A and discussion. We are at half time right now. So if you have any questions about the problems I encountered or why I did that, if you have anything to add, please do so. Yeah.
I would like to make a remark about the slide when you showed that you should capture this by shared pointer.
Yeah.
But this may lead to some really weird problems, like you're extending the lifetime of the object, and it may end up being deleted in some really strange ways. So it may help in this particular situation, but in general, I would say it's not the best way to solve this.
Okay, actually, yeah, I ignored one of the solutions to that. You can also capture a weak pointer and lock it, which is what we are doing most of the time. Because, of course, we're dealing with network problems, so we have latency, we have timeouts, and in this case, you don't want to have that thing living forever. Just let it die when the timeout comes, and when the timeout doesn't come, you just lock your weak pointer and work on this, what you wanted to do.
Yes, this kind of can help, but this may lead to some really more strange problems, because when you lock the weak pointers inside lambda, you actually extend its life, the life of this. And if this is going to be deleted somewhere else, it's not going to be deleted there. It will stay alive in your lambda. And it will end up being deleted when you finish your lambda. The lambda finishes. And this may end up in a different thread, in a different environment.
Yeah. This is something that you definitely have to consider. But I personally like to deal more with the problem, what do I have to do if this happens, than just saying, oh, I don't care, I just capture everything, and if it crashes, it crashes. So, yeah. I think you wanted to weigh in on that?
Yes.
Yeah, okay, so.
So, we ran into the same issue at my office, and we came up with two different solutions. So one from my colleague, he used the basic infrastructure of the software platform we're using. There's a job queue a global one that is cared for being started up and shut down elsewhere, and it's guaranteed that it's the last thing that happens when the application closes down. So, and he delegated the destruction of that that object that was being that had to execute the lambda call to that. And there's also a facility using weak pointers, as you suggested, to prevent executing it at all when it's too late because everything is shut down. Yeah. So that the other possibility was to prevent this shared from this, combine it with the depointer idiom. So you make the depointer a shared pointer, and when you execute this lambda, you pass it a weak pointer only. Basically, it comes down to the same as you, but for the external world, the object is gone already. Yeah, so you don't run into this problem that you globally extend the lifetime of the visible thing for other components. That's really nasty, I agree.
I have a question about the usage of lambdas in general, because I understood lambdas were something like in-place closures, for example, algorithms in the STL or something like this. And if you keep them small, if you use them only in certain places of your code and you don't want to reuse them or anything, I think many of the problems you just described won't even exist. So maybe I'm not sure. Maybe I don't get the point exactly of the talk, or maybe I'm getting lambdas wrong. But I think many of the problems won't even exist if you don't try to reuse lambdas all over the code base.
Yeah, that's a true thing. We actually so the reused lambda I showed you, we changed it internally to a function, to a higher level function that just returns a lambda. Still, we encountered the problem that if you do that, if you use higher level functions, then you are automatically reusing lambdas. And if you're doing that, make sure you know where you are. So if you're just doing it in a small scope and you don't go through different places, or you just define them and use them as they are, then you won't have the problem. Yeah, one small thing to that. As I said, using lambdas is, where is it? Much more efficient. So that's the code calling the call stack when you call the lambda. That's the call stack if you go through standard function and standard bind. So on our server, this one leads to an unnecessarily high load. So that's why we decided to use lambdas for even callbacks for network operations and that stuff. Okay. I think one other question was...
Yeah, just a short remark for the lifecycle problems.
Yeah.
If you're worried about which thread you get deleted in, we can do what we do, make a custom deleter that just dumps the delete call onto the right event queue.
Yeah, that's possible. That's quite possible. Just don't use it with UIs.
Yeah.
So one question regarding the std function. We use asynchronous calls as well with a lot of lambdas and mainly for boost ASIO. Since every lambda effectively has its own type, you need some kind of type erasure to capture them effectively. So putting them into an std function or something like this, which makes you end up with a call stack like that. Did you notice any performance implications of doing that, or how do you solve this problem?
basically, with old code, we actually just exchanged standard binds with lambdas often, so it didn't change anything really. With new code, partially even, especially in the solutions where we can use C++ 14 or 17, we're using auto parameters, so that's helping a lot. Okay, so if there are no more questions, I just hope I didn't waste your time too much and you did take away something. If you like to continue discussion with me about things, or if you want to know more stuff, if you're interested in how we're working with lambdas in more complex problems, you just can contact me via Twitter, I'm CNH13, or via my email. So thank you for listening.